In this video, we're going to look at the concept of straight line graphs and gradients of a graph. After going through this video, I guarantee you that you'll be able to understand the basics of straight line graphs and gradients of a straight line graph. Okay, so ensure you stay to the very end of this video. I'm going to simplify the idea behind this concept for us. Okay, so let's go into the details of this video. Now, let me begin by bringing out this graph to illustrate what I want to say now. Okay, so in this graph I have here, all right, so when you look at this graph, you will notice that basically what is happening here. Let's first of all get a scale of this graph. Let's get a scale of the graph. Okay, so the scale of this graph is 1 cm represents 1 unit on x axis, and we also have 1 cm represents 1 unit on y-axis. Okay, now when you look at this graph closely, on a typical graph, you will see many small boxes. All right, so each of those boxes represents 1 cm. So the scale of this graph now is 1 cm represent 1 unit on the x-axis. That's why you have, if you are going to the x-axis here, to the positive x-axis, you're having 1, 2, 3, 4. If you're going to negative x-axis, you're having negative 1, negative 2. The same thing is applicable to the y-axis. If you're going up, okay, so let me say for the y-axis, these are positive y-axis. These are negative y-axis. All right, and these are positive x-axis. These are negative x-axis. Okay, so this is basically what is happening. Had it been the scale of this graph is something like 1 cm represent 2 units. Each of the axes, both x and y, is 1 cm represent 2 units. Now, if you're taking a reading, or if you are representing it, tabulating it, it would have been, instead of 1, 2, 3, 4, 5 for each cm, it would have been 2, 4, 6, 8, 10 in that order. Had it been the scale is something like 1 cm represent 3 units for each axis. If you're tabulating it, it would have been 3, 6, 9 in that order. All right, but for this example, we have 1 cm represents 1 unit. That's why you're having 1, 2, 3, 4, 5 in that order. Okay, so this is basically what is happening on this graph. Okay, now let's look at the, remember in this graph we have our midpoint 0. All right, our midpoint 0 is somewhere here. Okay, so that's a midpoint. Okay, now in this graph, let me say this is a straight line graph. A straight line graph could run from here to this direction, or you can run from here to this direction depending on the points you have. Okay, we're going to go in details of explaining these points as we progress in the course of these concepts. Okay, now this is basically what you have to know about plotting a graph. Okay, now let's look at the idea behind gradients of a graph. Okay, so let's wipe this. Okay, so we want to look at how to find the gradients of a straight line graph, or is it that I call it gradient or slope? Okay, now so basically we are given these points. All right, so this A and B. So in these values we have our, let's begin with the point A. So our y2 will be our 50. Right, so this is our x, this is our y. Okay, whereas our x2 will be our 6, our y1 will be our 10, and our x2 will be our 1. And the general formula for finding the slope of a graph, that the slope m equals y2 minus y1 over x2 minus x1. So when you input the values, you're going to have 60 minus 10 over 6 minus 1, which give us 40 over 5. So the slope or gradient of this straight line graph will be what? 8. Okay, so let's use graph to illustrate this. All right, so let me get a graph and use it to find this. Show you how you can use the graphical method to get the slope if you don't want to do it directly like with this formula. Okay, now this is a typical graph. All right, this is the exact graph we need to get the slope of this graph. Okay, now let me tell you this. Remember, the scale of this graph. Now, choosing the scale of a graph is very important. All right, so choosing the right scale will help you to have a neat graph, and the scale of your graph will also help you to know if you will make your graph accommodate all your points or all your values. All right, so for this graph, I used let me write the scale here. The scale I use 1 cm represents 10 units on y axis, and I use 1 cm represents 1 unit on x axis. All right, so that's the scale of this graph. 1 cm represents 10 units on y axis, and 1 cm represents 1 unit on x axis. That's why I have at the y axis. Since it's 1 cm represents 10 units, I have 10, 20, 30, 40, 50, 60 in that order. Since for the x axis, I'm using 1 cm represent 1 unit, that's why I'm having 1, 2, 3, 4, 5, 6, 7 in that order. Okay, so the scale is very important, just like here. So with this scale I've used, it will make us to have a very neat graph that accommodates the points comfortably. Okay, so let's begin by getting the intersections of these points. So when our x is 6, our y is what? 50. So this is where the intersection will be. Okay, now when our x is 1, our y is what? 10. Right? Yeah, from what I have here. So this is what is going to give us from here. Okay, so let's go ahead and put the intersection. When x is 1, y is what? 10. So it will be somewhere here. So from here now, we will be able to draw our straight line. Remember, our midpoint, our 0 to be here. Alright, so when you draw this graph, get the intersection. So this might not be perfect intersection. It's just an illustration to show you guys basically what is happening here. Okay, so this is how the graph will look. Alright, so it will intersect together. Now from here, you can get your slope. Okay, you can get the slope of the graph. This is basically how you can find the slope of a straight line graph. So this is where the fifth intersected with the x at 6. So you draw it down here. So this is just like we're having an angle, right? We're having a right angle triangle. Okay, so this is the slope. Now from here, you can deduce or indicate if you are using a graph to show how you got the slope. So you can indicate that here is y2 minus y1 over x2 minus x1. Okay, so you see the same thing. This is our slope is an m. Remember, m equals this. All right, so our y2 is 50, our y1 is what? 10, and our x2, these are x2 6, these are x2 6, and this is, sorry. Okay, so these are x2, these are x1, right? So this is a y2 50, and this 10 here is a y1. Okay, so this is basically how you can get the gradient or slope of a graph. Okay, using graph to illustrate it. All right, so this is just an introduction, the basic concept behind the use of graph to get the slope. The knowledge of you knowing how to choose the right scale and knowing how to get the intersections will go a long way to help you to solve problems involving graph. All right, find the gradient of a graph, of a straight line graph, and the rest of them. Okay, so in the subsequent video, we're going to look at the straight line formula. Very, very important formula for straight line graph. Okay, so this is just an introduction to the science of graph. Okay, so that's it for this class. No practice question here. In the next video, I'm going to give you guys a practice question. Okay, so hope you learned something interesting from this video. Now, if you are new to the channel, be sure you check the description of the video below for a link to our Telegram channel. Click on it and join our Telegram channel for instant notifications. Also ensure you are subscribed to this channel by hitting the subscribe button for more videos like this. Like, share, and comment on this video. Tell me how you feel, what you have learned from this class. If you seem to have any specific questions to ask, feel free to leave your question in the comment section below, and I will ensure to give you a response. Okay, so click on the end screen above, and I will see you in the next video. Okay, thanks for watching.